When you're writing code, are you doing it right? That's the question that worries a lot of people and should probably be at least something that every developer thinks through. Design patterns are best practice concepts that we can implement into our code to make it better in some way. Think of them as guardrails to keep our code safe. In today's video, we're going to be looking at the fifth and final entry in the famous SOLID principle. The D stands for the Dependency Inversion principle. We're going to dive into what that means, how it should change our programming practices, and how far we should take it. For those of you who don't know me, my name is Tim Corey, and it's my goal to clear up the confusion and frustration around learning C#, because learning software development shouldn't be so hard. If that sounds like something that would interest you, I think you'd benefit from two things. First of all, subscribe to this channel, and second, join my mailing list. The mailing list is where you're going to get exclusive content and insider access. You'll find the link in the description below. Also in that same description, you'll find a link to my blog post on this topic, where I'll include links to the source code at the beginning of this video and also at the end. So let's start the conversation on the dependency inversion principle, which I'm going to call DI from now on, by looking at some code. I could do a nifty PowerPoint for you and show you the fun pictures that try to represent this issue, but I found it best to look at this in a practical manner. Here I've created a project in Visual Studio in C#. Now the principles of this video actually apply to any software development language, but since this channel focuses primarily on C#, that's the language we'll use. The code here I have is rather simple. It's a console application that simulates a really simple chore application. In fact, I've oversimplified it in order to hopefully make it easier to understand DI. We start off with our static void main, which is the entry point for our console application, where I create a new person object and new chore object. I assign the person object, which I call owner, to the chore object as the owner. So the chore is simply, it has the take out the trash property or chore name, and it has the owner. And then I do three things. I perform work and say 3 hours of work was done. I perform work again, say 1.5 hours of work was done. And finally, I say that the chore is now complete. Now, if we look at the actual code of this, in the chore class, we see the chore name and owner properties. And we have the hours worked property as well, which is actually a private set because we actually set that through the performed work method. And that way we can do more than just perform work, we can also do other things. Now I could have made that into a full property and put this stuff in a set, but I actually wanted it into a method. So we add to the hours worked, we write a new log or create a new logger instance, then we log out that we perform the work on and the chore name. When we complete, again, it marks the property is complete, done, and it creates a new log instance that says we completed this chore, and then it creates a new email instance which sends an email to the owner saying the chore is complete. So let's look at those two classes. Let's first look at the logger. It just does a console write line that says, hey, I'm logging this. And actually so does the send email. These are just simulations. They're not actually a full application. I want to try and keep this as simple as possible. Okay, so and finally we have the person class, which is just a really simple first name, last name, phone number, and email address. So that's it. That's our entire application. If we run this, I'll drag it over here. It says we perform work, which that's our first one. We perform work again, that's our second one. And then we completed taking out the trash, and we're simulating sending an email to tim@iamtimcorey.com. All right, so that's the entire application. That's all it does. Now, the problem with this application is it totally violates DI. So now we have some code in front of us. Let's talk about DI and what it is. DI states that high-level modules should not depend on low-level modules, but rather both should depend on abstractions, and those abstractions should not depend on details. Now that's a whole lot of fun words that kind of make it glaze over a little bit. So let's talk that through and what it means. So in this instance, a high-level module means anything that's calling something else. Okay, so for example, static void main, it calls into the person class. It also calls into the chore class. Okay, so it depends on the person class being there and the chore class. This would be a high-level module, the static void main, because it depends on something at a lower level. Now the chore class is actually a high-level module as well, because it depends on the logger and the emailer class. The emailer depends on nothing, and neither does the logger. These are what we call a low-level module. So the high-level modules, chore and program, depend on the lower-level ones, meaning I couldn't just change out how the, say, logger works, because that would break chore, which would break our program.cs, because we depend specifically on that specific class. So that's the dependency that we have. These high-level modules depend on the low-level modules. And that's what DI is saying we have to invert. Okay, we have to change the story so that the low-level modules depend on the higher-level modules. And in fact, it's saying that both should depend on abstractions. Now, there's a couple ways of doing abstractions, but the simplest way, and the one we've been doing a lot throughout this series on Solid, is with an interface. And an interface works doubly well in this case because of the fact the second part of the description of what DI is. It says that both the high and low level modules should depend on the abstractions, and those abstractions should not depend on details. Meaning those abstractions shouldn't have to know about how things get done. It should just say, these are the things that will get done. That's a really clear interface. And so interfaces are a clear way of doing DI well. Now let's start our transition to a DI type system by first working on this person class. It's a really easy one. It's a simple one. If I just right click on the person and do quick actions and refactorings and say that I want to extract an interface called iPerson, and I want all 4 properties, that's great. There we go. Really simple. I now have a interface called iPerson. So now what we could do, in theory, you might think, we come back over here, instead of saying person here, we could say iPerson. And now it's depending on the interface, right? Yes, it is. Now we did break chore, so let's fix that real quick before we go on. Where we say it's actually an iPerson. So, and email sender. See how I have to change everything now because everything is tied to the person class. And that's a dependency we want to kind of break. We want to invert that. Now, I have made this now, and I think that should be about it. If I build that, that should probably build, and it did, with no errors. So I've now got an interface to the person, but here's the deal. I'm still depending on the person class. I haven't really inverted the dependencies because this high-level module still depends on the very specific person class, even though I'm assigning it to an interface instance or an interface variable. And that's a problem because I'm still having to have that dependency at this high-level module, which is what DI is saying I shouldn't have. And in fact, whenever you see yourself doing new, so new person, new chore, a new logger, new emailer, All of these are tightly coupled dependencies on lower level modules. That's what we're trying to break. We're trying to break those dependencies on those lower level modules and instead work off of interfaces. So what we need to do is have some way of not having to say new person. Now this is going to start covering territory that gets into a different DI. And so we're calling dependency inversion DI. But probably a lot of you have heard about dependency injection. In fact, a lot of people get confused on the D in solid thinking it's dependency injection, and it's not. It's a different thing. Dependency inversion is the principle. Dependency injection is one of the ways that you make the principle work. It's not the only way. There's other ways as well. But it's probably the most common way, and it's the way that I would encourage you to go. But for the sake of this video, for the sake of clarity, I am not going to cover dependency injection in this video. I'm going to do it in one coming up very shortly. But I want to cover just dependency inversion because I don't want those two things to be associated too tightly together in your mind. There's other ways of going about this depending on your situation. With that being said, this is where it's going to get a little trickier or a little muddy if we're not careful. So let me be very clear here. At some point, you have to new up an instance. So it's going to be that somewhere in your application. But with it here and all over the place, that's a problem. So what dependency inversion expects is that you will centralize that into one place that you can easily swap things out. And so what we're going to do for simplicity's sake is we're going to create one class in console UI, which is the opposite of what I normally do. I usually don't put classes here, but I'm going to for this demo. I'm going to put one class here. I'm going to call it my, let's call it factory. Make it a public static class. And what its job is going to be is to new up instances when I need them. See, one place that has all the dependencies. So I will make a public static person, create person. I'm going to bring in the using statement for that. And I will just return a new person. Now, sometimes a factory will have something more complicated than that, but this is a very, very simple place and a very, very simple example that we're going to do here. Public static chore. Public static. Well, and here's where we actually need to change this to an I person. And we'll have to have an I chore as well. So let's actually wait on that. So I'll comment it out for now. So let's go to the chore and create our interface for it as well. Looks good. Does everything we needed to do. We'll save that and return a I chore. Now I can do that right away because when I created that interface, it also assigned that interface to the chore class, which is a really handy little step there. Now, before I create one for emailer, let's create it, but actually we're going to rename pretty much everything. So let's create it. And instead of iEmailer, iMessage sender. And I'll rename that. And I'm going to say send message. Okay. And now if we come back over to emailer, we have emailer as an iMessage sender. We have send message. I use that rename in the interface to rename this as well. And the reason why I did that is because maybe I want to send a different message, maybe a text message or a message through the database or something like that. Well, I can do that now because it's more generic as a message sender. Now, a logger is pretty much a logger. I mean, you can have different things that it does in the logger, but still do the same basic action of logging. Therefore, this interface will work great. So it'll be an iLogger. It'll have a log. Good to go. Go back to the factory, and we'll create those last two. Oops. iLogger. Create new logger. And a public static iMessage sender. That returns new, for it now, new emailer. Okay, so what have I done here? Well, I've created a static class that news up the 4 different types of class instances that I need to have. And I have accessed this now at the very top level at program.cs. So now when I need something like a new person, let's go ahead and comment this out for right now. So I'll just comment that out. Instead of doing this, new person, I can say factory.createPerson. And now I can just do owner.first name and all the rest. So let's uncomment this again. And I will do owner.first name. And yes, it's going to yell at me quite a bit until I get this, all the commas transitioned over into semicolons. Okay, so there we go. So now I have called this factory.createPerson. Let's do the same thing with this new chore. So instead of a chore, it's going to be an iChore. And we're going to say, instead of new chore, we're going to say factory.createChore. And again, we're going to do the same exact thing here. We're going to do chore name and chore.owner. And make these semicolons. Okay, so nothing else at this level has changed. Okay, so we've just gone interfaces instead of the actual implementations. And to get our implementation, we have called the factory to get it for us. So now let's go through the rest of our application and extract out the places where we have a new and change that over. Okay, so let's start with our logger has nothing. It just logs. That's great. Our emailer has nothing. It just logs or writes the console. So that's great. And our person as well has nothing. So we just have to go look at the chore class. Now the chore class has a owner, which is the iPerson. That's fine. But we have this new logger. Now what we could do is have this call the factory, but that would then create a dependency that I don't want. I want that high level to just give me what I need. So what I'm going to do is actually create a constructor for my chore class. So it's CTOR. And I'm going to say, give me an I logger. Let's call it just log or logger. Logger's fine. And also I want a emailer, which is an iMessage sender. Let's call it message sender. And if we pass these in as a constructor, then what I can do is create private variables. So I'll create a iLogger underscore logger. I want the underscore. And an iMessage sender underscore message sender. And then in our constructor, we can say underscore logger equals logger and underscore message sender equals message sender. So now we have two interfaces passed in at our constructor level. What does that do for us? Well, instead of newing up a logger, we just, instead of saying logger or create log, we actually delete that and we say underscore logger dot log. We do the same thing here. So underscore logger dot log. And for here, we say underscore message, whoops, it's underscore, not a plus, underscore message sender dot send message. So what have we done? Well, we passed in two interfaces into our chore class. We use those two interfaces to then make calls to both send a message and also to log a message. So there are no more newing up of class instances except in that one factory class. Now it's yelling at us here because it's saying, hey, I don't have the parameters I need, which is not a problem because we actually have access to the things we need in this class, in this factory. We can pass in first we need a logger, so create logger. And we also need a message sender, so create message sender. Okay, so we're just going to pass in a new logger instance and a new emailer instance into our chore class. So what happens now? Well, now there are no more dependencies, except at the very top level, I have to actually ask for that factory.create person. Everything else is taken care of for us by the factory. So now, if I run this, as you can see, nothing has changed. Okay? So I didn't break anything. Everything still works the same way. Except let's look at our application. Where do we have a new instance? We're newing up something. Nowhere except factory, right? What does this do for us? Well, it disconnects us from everything. So that if we came along and said, you know what? I want to create a new class. Instead of emailing, it's going to be texting. So I'm going to create a new class. So I'll add that. New class. We'll call this the texting class, not testing, texting class. Well, let's call it texter since we have emailer, texter. Public class texter, which implements the iMessage sender. We'll implement that. And instead of exception, we're going to say, let's go with a $, a couple of double quotes. And in here, we will say, I am texting person.firstname to say message. Okay, so now we're going to know that it's texting this first person to say this, instead of emailing. So instead of sending that, sending an email to this person, we're going texting. One more note, it still says iEmailer in the class, in the actual file name, even though it's iMessage sender. Let's change that. Little details are important. Okay, so now it's very clear what that is. Okay, so we haven't changed anything yet, and in fact, let's run this again. It still says simulating sending an email to Tim at IamTimCorey. But what if I come to this factory and change this from emailer to texter? And I run it again. I am texting Tim to say the chore, take out the trash, is complete. You see how my application changed? It changed immediately with nothing broken. I didn't have to worry about breaking anything because I have no direct dependencies. I depend only on the abstractions, not the implementations. So let's talk about those benefits of doing it this way. And the first one, like I just pointed out, is the fact that we can make a change to our application in one piece where we replace, say, emailing with texting and nothing breaks. We just swap out that part and everything still works the way it used to because we did not depend directly on that instantiation. Remember when I changed the person to an I person and I broke the chore instance and I had to go to chores and fix that and all the rest? That is broken now. I don't have to do that. Broken in a good way. I don't have to worry about that because if I swap out this create person, instead of the person class, maybe I have an employee class instead, no problem. As long as it still has the same contract, we're good to go. So that's benefit number one. Benefit number two kind of links into that, and that is now my application is not this one big monolithic application. It's a bunch of really little parts. And this is where Solid really takes us as a whole, is it takes us into having lots of really tiny little parts, things that do only one thing, things that don't have dependencies, things that are just self-contained, tiny, and against an interface, so that I can unplug and plug in something new without problems. So for example, if I look at the logger class and I say, okay, I need to make a change here to do something different, no problem. I'm making one little change to one little piece of the application. I don't have to worry about the implications to the rest of my application as long as I still fulfill its contract, and of course, as long as I don't change the logic in a way that the application was expecting, or rather wasn't expecting. Okay, so it does allow me to really just work on this piece rather than this project or this solution. Just this little piece, and it kind of breaks it down so that I can make small changes and tweak my application without having big issues to concern myself with. I mean, imagine if I had to change this application. This is a small one, but imagine if I had to change this application before, when I started, to say, nope, it's an employee class now. I have to change multiple places just to make that work, and then I have to make sure that I didn't break anything in those multiple places. Now I don't have to. Another thing it does, this is a third major benefit to allowing this or doing this, and that is I'm now set up for dependency injection. Remember I said this is dependency inversion, but the dependency injection is the implementation of this principle, or one of the implementations of this principle. And so what dependency injection does is it takes away the need to do this, that factory.createPerson, or the actual creation of the factory. Dependency injection, what it does is when it comes across a class like chore, and it looks and sees, oh, the constructor says it needs two classes. No problem. I'll go get those classes. And it goes and gets them for you. So it kind of handles all that stuff for you. And along with DI, or dependency injection actually, also comes the ability to have IOC, or inversion of control, which again is more of a talking about how this principle applies, but also a lot of IOC containers will allow you to not only have dependency injection, which is where it finds these items here and replaces them with the actual instances, but also the fact that it can dynamically change those instances or get different ones depending on either circumstances or what you provide it. For example, I've used a tool called MEF in the past. That's the Managed Extensibility Framework. And it's what Visual Studio was based on. And if you notice, Visual Studio has this ability to add things to menus and to kind of plug in extra stuff right into Visual Studio. Well, how does that work? Well, what they do is they have a tool called MEF where it actually has, again, dependency injection, but it goes and looks for certain DLLs and says, do you have more things I could add to my DI pool? So it's kind of like having this right here, but you have a tool that goes out and actually looks for DLL with more of these. And says, oh, you have 3 more loggers I could add. And so it brings those 3 in as well. So there's some fun stuff you can do, and that's kind of like, I guess, benefit number 4, is that once you have this dependency inversion, you also have the ability to have dependency injection, but also the ability to then inject dependencies from other sources in a plugin type framework or a really dynamic application style. Now, that's way down the road. That's way on the complicated or end game type levels. But even if you didn't do any of that, even if you didn't even do dependency injection, and you say, you know what, I'm just going to do this factory thing and that's all I'm going to do. You're going to create my factory. Cool. If you do this, then you have an application that's disconnected from each other, where nothing depends directly on either the higher level or the lower level classes. And instead, everything depends on interfaces. And that means you can swap out parts as needed to upgrade your application. That's huge. And this is the next benefit is not only can you swap these things out, but benefit number 5 is you can unit test this thing. That's huge. We looked at unit testing already a little bit on my channel, but we're going to go into it in further detail and soon, because once you understand how to do this, then you can unit test all this stuff without affecting anything. Let's for a minute think that, remember back at this application before we had this injection of these interfaces. Before we had any interface, we had newing everything up. If I was going to create a unit test where I create a new chore instance, I added the chore name and the owner, and then I said, I want to test to make sure that the complete chore works. Every time I ran that test, it would have newed up a logger instance, which would have written to a log file or written to a logging database, whatever it did, and also new up a message instance and email a user. That's a problem. I might run my unit tests 50 times in a day. Well, if I did that, I don't want my inbox filled up with 50 emails, and I don't want my log files filled up with a whole bunch of tests either. So that's just not a good idea. But because we are so tightly bound to the new emailer and new logger that I couldn't separate this out. Therefore, the complete chore method was untestable. So was the performed work method for the same reason. So therefore, I couldn't really test this class hardly at all. Now, since I'm passing in an iLogger and a iMessage sender, I could create my own class instance that would apply this iLogger interface. And what it would do is just say, yep, I logged it. And yep, I emailed it. And then I could pass those into my chore instance instead of the real ones. Now I can test the complete chore and just make sure it called my logger's log method and also my message sender's send message. Okay, so I can check those things now and I can test those things without having to actually affect real data, without writing real log messages, without really sending emails. Now you may think, man, that sounds like an awful lot of work creating new class instances and making sure they implement the contract and all the rest. And yeah, that would be if it had to do it manually. But I don't. It's a thing called mocking. And we'll get into that. But essentially what it does is it allows me to create really quick implementations of any interface that pretend to work so I can test to make sure that my real code, which is this chore class, these two methods here, the perform work and complete chore, that I can test to make sure those do what they're supposed to. Now you might think, yeah, but you couldn't test then the logger, because the logger probably writes to a log file. Well, guess what? Instead of actually passing in an actual log file, we're going to try and pass that in as an interface as well. So there's a lot of ways we can go down that rabbit hole. But essentially, when you think about it, if you ever see a new somewhere, you've got tight coupling. We don't want tight coupling. We want loose coupling. We want to talk to just interfaces. And so if we do that from top to bottom, or from bottom to top, either way, if we do that through our entire application, then we can break apart our application into little pieces. We can test each piece. We can replace each piece. And we can use something like a dependency injection framework to actually assign actual instances to each of those interfaces. So that's what the dependency inversion principle is all about. The idea that we don't have new anywhere in our code, that the program.cs does not depend on chore or person, and that chore doesn't depend on the logger or the emailer. Instead, everything is disconnected. So that's it. That's all dependency inversion principle talks about, is just that disconnecting and everything talking to interfaces. All right? I hope that you've understood this. I hope that you kind of grasp the concept, because I tell you what, if you can implement, especially this, but really all the solid principles, they're really great. And if you implement all of them together, they kind of form this one larger way of thinking about applications, where your applications become more disconnected, they become easier to maintain, easier to test, and easier to work with. Down the road, you're going to thank yourself if you do that, because your application's always going to need to be upgraded. Think of it this way. What if your boss comes tomorrow to you and says, that big, huge application you work on for, the past 6 years, I know it runs on SQL right now. We need to run Oracle. If you had properly implemented Solid, not a big deal. I mean, it's not tiny, but comparatively, yes, it is. Because if you haven't implemented Solid, you got calls to SQL everywhere. Think if he said, you know what, we're going to change out our logging framework from, say, Log4net to nlog. And you go, well, sure, but that's going to take us probably touching every piece of code and testing it, and it's going to take, 6 months to do. And he says you have a weekend. That would be awful. But with implementing Solid properly, you go weekend, sure, I can have it done in the next 3 hours. Because I'm only changing it in one place, I'm only changing a few methods, and since I'm writing against interfaces, no problem. I create a new class for nlog, and I take the same interface and implement it with nlog and just say, here's how it works instead. And I'm done. Everything still works. And as long as you test that one small new class you created, you're good to go. So that's really the power of Solid. The idea that everything's disconnected, everything's replaceable, everything is modular. So you don't have one large car to replace. You can just replace the spark plug, or you can replace just the hubcap or the wheel. All right. So that's why I'm so much of a fan of Solid, and why I want to make it as clear as possible. Because once you get it, it really makes your code better. And that's, again, coming back to that, are you doing it right when writing code? And if you are implementing Solid, you're much closer to doing it right. So that's it. Let me know what you think in the comments below. If anything was confusing, I'd love to hear about it. And I will be doing follow-up videos on other principles, because there's more than just Solid out there for design principles. So we're doing more of those. And I'll also be covering things like more advanced unit testing with mocking, and also dependency injection. So they'll be coming down the road. Make sure, if you're not already subscribed, to do so you can get alerted when those come through. All right. Thanks so much. And as always, I am Tim Corey.